Alrighty, we should be live. Alrighty, back to soldering today. So I mounted the mag base on a steel plate which is underneath this mat, so this isn't going anywhere today, and you've got a nice view over here of what I'm doing on the board. So the iron niche is hot. I've got a board ready. I haven't got my resistors ready. That's not good. Let's sort that out. There we go. Get some flux. Move the solder clean a bit closer. Let's promptly attach itself to the magnet. Good. That way we know it's magnetic, eh? So you should have a nice angle on what I'm doing with the soldering today. So I'll move the camera closer. And it's also sturdily mounted today. I forgot my spectacles. Let's fix that problem. Good. That is better. How are we all doing today? Looking forward to the weekend. Got plans for the weekend? I'm trying to think of what to do for the project for the weekend, because I've got 10 more of these boards to solder and test. Well, solder, then they're going to be cleaned, and then they can be tested. Cleaned, dried and tested. That's the order of operations. So let's get our 2K. Let's start on the 10Ks. I took today off, so it is basically a 4-day weekend for me, although I'm technically working, but if I can finish my work today, then I can have today and tomorrow for projects, technical stuff. Maybe finding something interesting to make a video of to show you guys. The one thing that I do have, which is a byproduct of the work I do, is some I2C 420 milliamp transmitters. So I think that would be quite neat to hook up an Arduino to one of those, and I can teach a little bit about how 420 milliamps works and how to control it from an Arduino. Wouldn't that be nice? I've got two of them. The one is 0 to 10 volts, so we could play with that as well, but the one is 4 to 20 milliamps. For many people, 4 to 20 milliamps remains a mystery, so I think that kind of helping to clarify that a bit might not be bad. Because it's a control signal in the form of current. So the current passes through a resistor called a burn resistor on the receiving end, and the receiving end then measures that voltage and works out the current from that, and works out what value, a reference or process value or feedback value, it can be any value, it's an analog value, that being sent over 4 to 20 milliamps represents. So it can be control or feedback. You can be, in our case, it very often is a reference to a variable speed drive. But the other thing we see a lot with pressure feedback or pressure transducer, which is normally current, 4 to 20 milliamps, and then pressure control is done, and that drives internal PID. Now the reason one uses current is because it offers noise immunity, number one, because to induce noise into a 4 to 20 milliamp loop you need a lot of it. It can happen, but it's extreme cases. So it's a lot more resilient than a 0 to 10 volt signal. The other thing is that being 4 to 20 milliamps, 0 milliamps means that you have a wire break, and the system can therefore report this error, so it's a safety. So for mission critical stuff, 4 to 20 milliamps is a must, because at 0 to 10 volts you could have a broken wire that would still look like 0%. Whereas with 4 to 20 milliamps, if you go to 0 milliamps, you lose your current. And you know, on a broken wire, and your process control software can raise the alarm. So that's why it's pretty much an industrial standard for analog values and process signals. So we've only got 10 to do. I did some soldering off camera last night to just get some more of this done, because I have nearly 30 of these to make. It's quite a lot. So now there's only these 10 left. So this shouldn't be too long a stream. Let's get the components on, get the pins soldered in, then they can go to cleaning in my kitchen. That's right, in my kitchen. Don't think that would work too well with family life. It's normally frowned upon. Right, one down. 9 to go. Suppose people are either sleeping or